So our next talk, John, we're going to welcome him to stage. Hands up who's got a security camera at home? Yeah, see, like most of the audience, which is exactly what I expected. I guarantee this one will be fun. Please make John feel very welcome.
Hi, everyone. So I bought a security camera online, and when I did so, it really was for home use. It wasn't designed to be like a hacking platform or target, and I had no idea that when I bought it, I would end up in Brisbane speaking to probably the largest audience I've presented to, dealing with the adrenaline dump that comes with a large audience, but here we are. So, like any self-respecting security professional, when you buy one of these cameras, you're sort of duty-bound to work out the security around it, because you don't want to put in some random thing in your network and have no idea what it does. So I took it upon myself to figure out, to buy a camera, figure out how it worked and how much work it would need to be sort of an acceptable device within my home network. Best case scenario, I have to put it in its own dedicated IoT VLAN and not let it talk to the internet. Worst case scenario, I'm sort of having to crack it open, finding UART ports or dumping JTAG, dumping SPI flash and so on. So that was kind of the setup for this whole thing. And is that gonna? No. Hey. Okay, so that's kind of the setup for the whole thing, and I want to go through how I attacked it, some easy wins at the start, some setbacks, maybe some sort of philosophical thoughts about those setbacks, and then getting back in. So let's start. So it arrived in the mail about a week later, and it was one of the most generic sort of packaging boxes I've seen. There's absolutely no vendor on it, no marketing, no branding, there's nothing. The only thing on there, even the sticker didn't have information about who the vendor was. And the only thing that identified as a Yi-kes was the piece of paper, which was the manual at the bottom of the box that I didn't spot until a little bit later on in the piece. And that little slot you see on the far right, that's the micro SD card, presumably for recording video, but it also makes it really easy to access, which is good for a security camera that would be outside. So on the side of the box, we have this branding, or not branding, some information about the device. So we have something called Smart Link, and I'm not sure what that was. We've got mobile viewing, we've got two-way audio, so it's got a speaker camera built in. It's got a couple of motors, so it can move left and right, up and down, and it's got the IR LEDs, so you can see at night, it all sounds good. One of the reasons I bought it. And I've done a few of these cameras before, and one of the things that I usually start with is the web interface. Usually, when you boot up these things, it comes up as a hotspot. You pair with your laptop, and then you can configure the device to pair with your home network. And usually that's a really good attack surface to start with when you're looking at one of these devices. And a lot of the time it's like hacking back in the 1980s, because there's lots of easy vulns, and even if you're doing binary level stuff, there's usually no dep, no ASLR, so it's a nice and easy target for hacking on. But in this case, there was no HTTP. There was a couple of 6,000 level ports. I have no idea what they do. But I saw 21, and I know what FTP is, so I started with FTP, and it prompts you for username, password. You can Google, maybe someone else has done it. You can use Google Docs, they're great. Anonymous is usually a good one, or you can just skip to the end of this list and do what I did and just try root, and sure enough, you get straight in, and so that's cool. But if you were hacking like a site online and you get in as root, there's a good chance you're either in like a sandbox or a Docker container, or maybe a high interaction honeypot. So it's not a guarantee that you are actually root. So you dig around a little bit, and there's a couple of files that are useful. One of the ones that we'll see later on is called proc self environ, and so proc self is like a special file root that gives you access to the current processor's state. And one of the files in that is the environ file, which dumps the environment variables of the currently running process, which in this case would be the FTP daemon. And we can see here we are actually root on this device. It's not some UID remapping thing. And so that's cool. A bit scary, but cool. And the other file I like, especially on embedded devices, to pull is proc self mount. And that tells you information about the file system. And you can sort of see here, there's the root file system is using squashfs, which is obviously read-only. And then further down, the two towards the bottom are the MTT block 5 and MTT block 6. And they refer to the flash device, the storage. MTT block 5 is user, which is also squashfs, so that's read-only. And 6 is interesting because it's mounted at etc JFS2, and it's the JFS2 file system in which is mounted read-write. And so when you're looking at trying to sort of improve your access, in this case, you're trying to find things that you can write to. So one of the things that I would like to have been able to do is to backdoor some binary on the device that would get executed from something I could do on the web interface, and so I could get a reverse shell that way. But that doesn't look like it's the case in this case, particularly because this device is also using BusyBox. And BusyBox is basically the entire user space compiled into a binary called BusyBox. And BusyBox works out what command you're trying, like cat, based on the symlink that's going back to the BusyBox binary. Anyway, we'll look at that a bit later. So I'm poking around on the device, using my FTP access to pull anything I can think of that could be useful to try to escalate privileges on this box. And there's not much, it's pretty slim pickings because, again, most of it's read-only, so I can't do much. But I eventually pulled this file called etc profile. And etc profile is read by pretty much anything that uses, as it says at the top, sh bash, ksh ash, and so on. So all the shells will read etc profile. And it looks like a fairly standard etc profile, except for the very, very last line where it says source etc JFS2 time zone. And again, this is the writable file system. So it's going to load this file every time a shell operates on the device, or a shell is open on the device. So etc time zone really is just setting the time zone. In this case, that's to -8, which I believe is somewhere in mainland China, which would make sense. But there's nothing stopping us from uploading a new version of the time zone. And so this is what I started. So I started off with just the line touch/temp, John was here. And one of the things that I found after many bitter experiences was that it's really important on embedded devices to avoid doing things that can interrupt the boot process, because if something in here returns an error, it could mean that you don't get further on in the boot sequence, which means that you may not get the network, which means that you can't get back in. So you end up with instead of a smart home security, you have a dumb home security camera, which is not so cool. So I wrote the line touch John was here, uploaded a new time zone shell script, rebooted. Sure enough, I got a file called John was here in temp. So I knew I had RCE at this point, but I want reverse shell. So I pull a simple reverse shell of one of the lists, which is the one you see on the bottom pane, which is my runme file. Runme, you'll notice, is executed from time zone, backgrounded. And again, that's something you want to try to do to avoid delaying or blocking anything in the boot sequence, because again, you can soft brick your device. And initially this didn't work, and it turns out that the Wi-Fi network hadn't been established that early on in the boot process. So something was running, it was spawning a binsh shell or bash shell. It was running my reverse shell, but there was no network. So by adding a sleep of 120, I was able to wait long enough for the network to be up so that the reverse shell connected. And sure enough, if you listen on your own computer on port 4242, you end up with a reverse shell when you boot the camera as root. So that's awesome. So now I can sort of move laterally or move in the device and work out what else we can do. But just taking a step back, my goal here is to find out whether my security camera that I purchased for $25 on AliExpress is worthy of going into my home network. Is it safe enough? And so far we found that FTP credentials are wide open, and that's not really I mean, it's a bad thing, but if someone is already on your home network and able to access this device, there's a lot more bad stuff they could do. So it's not huge. And you could get a reverse shell. Maybe you could use this device as like a point of persistence within the network, and that's bad, but it's not hugely bad. So I'm okay so far. And I still don't know how to configure this thing like legitimately, but this is the point in time where I find that piece of paper at the bottom of the box, and it's how to set up your smart camera. And you can see there's a QR code to scan to download the Yi-IoT app. And there's also instructions to say you've got to set up an account, and then the app will generate a QR code. You scan the QR code in front of the camera, and it says pairing successful, and you've got some way to view the feed and control the audio and so on. So that's how you configure this thing. And I'm reading the instructions this time. So I downloaded the app from APK Pure and decompiled it and loaded it up into VS Code. And I used my mad Control-F skills to figure out where in the app the QR code was generated. And very quickly you end up with this function in there called gen barcode. And between lines 410 and 419, you can see it's building up this string. And you can see on 418 it says QR code string equals the string. So we know we're close. And so the gen barcode function basically says build a string that starts with b equals, and then something called a bind key, it's not important, ampersand, s equals, and then the base 64 representation of your Wi-Fi name, ampersand, p equals, and what appears to be the base 64 representation of your Wi-Fi credentials, your password. And that all looks pretty straightforward, except you'll notice that in the get base 64 function up in 405, it takes a bool. And you wonder, why would base 64 need to take a bool? Well, get base 64 function conveniently immediately follows it, and you can see if that boolean, z in this case, is false, it drops right down and just returns the base 64 encoded. So the SSID is just going to be the base 64 encoded representation. The password, on the other hand, goes through this loop, and it goes through a for loop that basically takes every character from your password and XORs it with something called key at the same index. So it walks through the key, it walks through the password, and it walks through the key, and when the key gets to longer than 70 characters, it loops back around. And so that's what they're using for some sort of encoding or encryption mechanism. But what we can determine so far is basically the QR code is the SSID and some encoded version of the password. So what is the key? Well, again, if you scroll right up, you can find the key in the clear in the top of the function. So it says key equals 89 blah 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 blah. So we've got the key, and forgive my French here, but I think this is called the Vigenère cipher, and this was all the rage back in like the 15, 16, 1700s, and there's actually a special case of Vigenère where the clear text that you're trying, or the ciphertext that you're trying to encrypt, decrypt, is shorter than the key, and that's essentially a one-time pad, and everyone knows that a one-time pad is basically uncrackable, except in this case it's not a one-time, it's every time pad, I guess. So, and just for a thought experiment, imagine that we weren't able to get the key from the firmware, because obviously the camera would need a copy of this key. Imagine the APK did not have the key either. Imagine that instead the app prompted you for your Wi-Fi name, Wi-Fi password, and it sent it off to some server, probably in China, and the key was encrypted there using the same mechanism. Would that be secure? And no, not really, because if you set your password to 70 A's, the key will come back XORed with the key, and then if you XOR that key again, you will get the private key. So, and I'm not the first person to figure this out. There's a guy online goes by the Crypto, and he basically used this approach to reverse engineer the key without having to touch firmware or the APK. And if any of that's useful or interesting, I can strongly recommend Dan Bonnet's Stanford Crypto 101 course and the Crypto Pals course as well. They're really good. But we've actually seen a QR code before. There's one in the manual. And just out of curiosity, it was interesting to see what that decodes to. And unfortunately, or fortunately here, the vendor has been smart enough not to put in a password, although it's also possible that this is just an open Wi-Fi network. And so in this case, there's no password on the manual, but it sort of occurred to me, and I don't know why, but what if other vendors are using the same firmware or haven't been quite as aware of what's going into the QR code? So I did a quick search, and sure enough, there's another company which appears to be related somehow called Mi. It's also known as Xiaomi, which is someone I had heard of. And in their iOS connection guide, they actually have a sample QR code, and if you scan it, you get what looks like to me looks like a very valid PSK, a password for their Wi-Fi. And so, yeah, maybe people aren't so aware of what's going in, no, even vendors aren't aware. And so I did another quick QR code search. Oh, sorry, before I get there, yeah, there was, if any of this is sounding familiar, but lots of different brands reusing the same hardware. There was this report from Consumer Reports, it dropped last month, and they found that there was about 10 or more seemingly identical video doorbells, all sold under a range of brands, but they were all basically the same product at the end of the day. And that probably explains why this product is very generic. It's probably being resold under lots of brands. Also interesting was that this particular doorbell camera, you could take full control of it simply by walking up to it, pressing a button, downloading the app, creating a QR code. And so, yeah, this is becoming a little bit more mainstream, I think, the QR code scanning for configuring. And this particular TechCrunch notes that the Awits app has more than 1 million downloads on Google Play. It might interest you to know that Yi IoT app has between 5 and 10 million downloads, and the Mi app has between 50 and 100 million downloads on Google Play Store alone. And obviously the error bars there are going to be pretty big, but it's not rookie numbers. There are quite a few of these cameras out there. And so again, if vendors don't really know what's in these QR codes, maybe other helpful how-to guides and bloggers have also misunderstood or not been aware of what goes into these QR codes. So I searched, and sure enough, there were a lot of hits in Google Cache. And there are also more hits on YouTube, but which didn't seem to make it into QR Cache, into Google Cache rather. So what I did was I scraped the first 100 images just for fun and wrote a script to see if any of them adhered to this B equals S equals P equals, to see if other people had been putting their credentials online. And sure enough, out of the first 100, I found 5 hits for people who have essentially published their Wi-Fi creds. And so that's not good. But again, if you're thinking like, who knows where Workaholic or Doodle's home is? Well, it might interest you to know that there's a site for that called WiggleNet, where people who have been war driving will dump databases geolocating your SSID, and you can type in SSID names or your base station's SSID, and it will geolocate it to within a few meters. So, and this is not the only one, but this is probably the most popular one. So that's cool. But again, is it classy enough? So we found, yes, we can backdoor our own camera. We've also found that there are probably hundreds, maybe, of people who are publishing their Wi-Fi credentials. It's cool, but it's not really classy enough. I think we need to go deeper. So let's start on the firmware of the camera. So I use my mad, again, Control F skills to identify that QR code. The 3 binary files that we see here may have something to do with QR code. And I threw the first one in Ghidra and Control F for QR code. And the first hit was for this function called ACK-Yi QR code scan. And I walked the calls tree for this, and it's right at the start of the function, it forks a thread that will run this function in a loop. And what that means is that this camera is looking for new QR codes even when it's already configured and working correctly, which is cool and will be important later. And so the function's pretty long, and Ghidra does a great job, but it's still not as easy to understand. So I've written some pseudocode, and this is kind of important to understand. So essentially, every so often, this function will be run, and it will take a dump of the frame buffer from the camera. And it will identify a string if there is a QR code, and if the QR code is viable, as in it follows that B equals S equals P equals syntax, it will take down the Wi-Fi, put it into scanning mode. It writes the SSID and the password in the clear to a file on /temp called Wi-Fi info, and it then calls this script called Wi-Fi station. Then for the next 5 minutes, it will sit there running the command WPA CLI status, looking to see whether it has successfully paired. If it has, then it overwrites the Wi-Fi config with the new config, and if it can't within 5 minutes, then it just reverts the Wi-Fi and brings it back up, and it works the way it was before. Okay, so what does this Wi-Fi Station Connect script do? So the first thing it does is use awk to pull out those variables from Wi-Fi info, so SSID, password, and security. I don't know what they are, but that's cool. Following the bouncy ball, we found that Wi-Fi Station Do Connect is called with those 3 parameters set. Wi-Fi Station Do Connect takes those 3 parameters and calls a second script called Station Connect. Okay, so what does Station Connect do? Station Connect does something weird. It takes those parameters, the SSID and the password, and it wraps them in these double quotes, single quotes. And I thought that was kind of weird, and it sort of stood out to me, but whatever. And then it takes those and it throws them into a function called, it calls sh-c WPA CLI and then the SSID. And remember, that SSID is attacker controlled. And if you're sitting there in the audience or at home and you're thinking, hey buddy, that kind of looks like command injection to me, yep, you'd be right. That is command injection. So we can put values in there and cause them to get executed. And so here's kind of the setup. On the top left, we have the first script, which is the one that the firmware will call. And it basically just takes a file called test, uses the same awk command to extract the SSID. It then calls the second stage, which is the next box below. So stage 2 wraps the SSID in double quote, single quote, and then it just calls sh-c ID instead of WPA CLI, and then the $SSID. And as my test input on the top right, I have A, because we need something, double quote, single quote to terminate the quotes, to make it like even, and then semicolon, echo, I have RCE, and then using hash to comment out the rest of the line. And it kind of feels a little bit SQLi-ish. And then on the bottom, we can see it going end to end. And the second bottom line is it's calling ID, and it's saying, hey, there's no such user as A. And then the next line is I have RCE. So I have RCE using a QR code. And I tried it by creating a QR code that just writes a file called John was here too to temp, and sure enough, that works. But before I do the funky chicken dance in the end zone, I need to test it end to end. I want to get a reverse shell. And that didn't work. And it took me a while to figure it out, but essentially there are limits to how long the commands, those SSIDs and the password can be. And if you look right at the bottom, the mem copy is only copying OX40, so 64 bytes in decimal bytes from the QR code into the Wi-Fi info file. So I've only got 64 bytes to play with. And 64 is a big number, right? This should be easy. So the first thing I tried was using curl. I've used the integer representation, didn't actually save that many bytes, but integer representation of an IP address. And the idea is it would just reach out to the IP, pipe whatever the output of that, the result was into SH, and that would backdoor the camera, and we would take a reboot to execute that backdoor. And it turns out that this version of BusyBox did not include curl, so that was a no-go. But no, there was a wget symlink to BusyBox, so we should be set here, and wget -o- behaves almost exactly the same as curl, so this should be good, right? And it turns out no, because there's no network at this point. You can't call out to a remote IP address when the Wi-Fi has been taken down right at the start. So that was no go. What about just waiting for longer than 5 minutes so that the Wi-Fi comes back up? Surely that would work, right? So no. It turns out that while there is a symlink from user bin wget to busybox, the busybox binary did not have wget installed. That's no worries. We've got netcat. We've already used netcat before, so that should be fine. And to try to keep it within the 64 bytes, I've used this redirection thing. So at the end, it goes E star, and the only folder starting with E in the root file system is etc. The only folder starting with J in etc is jffs2, and the only script that ends in H in jffs2 is timezone.sh. So this should work, right? No. It turns out busybox doesn't support wildcard redirect, and it also turns out that busybox doesn't support integer representation for IP addresses. So this is kind of what I want to do, but it's too long. So I kind of screwed at this point, and I decide to go online and Google and see if someone else has figured out how to do this in less than 64 bytes. And this is where it kind of went all horribly wrong. So as I was Googling, I came across these reports from Talos, and there were a lot. So there was like 12, 20, somewhere in there, CVEs from Talos for this specific camera. And I'm not sure what the group name is or the collective pronoun is for a group or set of bugs, but I kind of like to coin the phrase, it's a swag. So I could, if I was to use it in a sentence, Talos had already found a swag of bugs with my camera. And if there's one thing I know is that, and one of them, the base 64, QR code base 64 code execution looks very, very similar to what I've found. And you can see here, they've created an SSID called toteslegit, $echo ASDF output to lol.txt, and sure enough, they get command injection. So refinding old bugs, it might be cool, but it's not classy. So yeah, so I'm kind of, looks like I'm just looking at an ND, one day here, or ND. But then again, I used my mad Control F skills, and I found references to dates as late as 2001 in there. So this is actually new firmware. So this is patched. And so these are all new and improved bugs that I'm dealing with. And that's cool. And you can kind of see echoes of the fixes. So you remember I was talking about that double quote, single quote thing? That's probably the fix for the Talos CVE. Because if you wrap single quotes around, say, $, $ID end bracket, it won't execute. But I'm not using that. I'm terminating the quotes and using the semicolon approach. So that's why I didn't hit this. And it was interesting to note that Talos didn't seem to have much luck either. They said it was 32 bytes long. It might have been on that firmware. And they also noticed that curl, wget, and netcat are not natively on the box. So I figure at least I'm in sort of good company. They weren't able to get reverse shell either. And this is kind of where I gave up for a long time. And because it's a bit disheartening to find, to spend time not being able to get somewhere that you wanted to get to. And I'm not sure if I should even go down this path, but it's kind of interesting to me trying to figure out how to spend my time in the most valuable way. And I don't know about you, but I spend a lot of time, hunting bugs and developing exploits and so on. And you often read online all these people who've, dropping exploits one after the other. If you read, a lot of stuff online, and it's sort of not my experience. There's like this disconnect between, hey, everyone's dropping vulns here, and I'm struggling with, what ends up just being a null dereference, so it's just a DOS or something like that. And, you sort of get bombarded with statements like, get good, or it's a skill issue, or just try harder. And I think in a lot of cases, I don't think it matters how hard you end up trying. Sometimes it's just not exploitable. And so that's not really, that might be more accurate, but it's not really helpful. So I've been thinking about this, and I think I've noticed two things. So I've noticed that when I've asked for help from someone more experienced or anyone else in the field, simply trying to articulate what my problem is in words has helped. So I think asking for help is a good thing. And I've noticed, and I think there must be a name for this phenomenon, but have you ever noticed that when you type out your problem and you hit enter, like 5 seconds later, before anyone's responded, the solution comes to you and you say, never mind, figured it out. And so asking for help is good. I also found that, again, I have no way of measuring this, but if I were to estimate my success rate at knowing when to pursue bugs and invest that time, my hit rate or my percentage of being correct would be probably less than 50%, which is kind of remarkable when you think about it. That means tossing a coin would probably be better than me trying to figure out whether it's worthwhile spending time investigating a bug. So I guess the takeaway from that is, if you are sort of more experienced in the field, please, try to help out those people who are asking questions. And if you are one of those people asking questions, please ask good questions, like make sure you've done a lot of, everything else that you can think of before you start bugging people, to try to keep the signal ratio high. But I had a really good boss, and my boss would prompt me every sort of one-on-one, and he had this knack of knowing when to push me and push forward with investigation on a bug and when not. And so, thanks, Trenton. And so he, a couple of months later, he would say, what about this thing? And I took his advice, and I kept looking at it, and I'm pretty sure I was looking at this code and chuckling at the fact that they thought double quote, single quote would be enough to stop command injection. And then it dawned on me that they've added double quote and single quote to the password and the SSID. And you can see that there's a shell script like 2 lines after the command injection for SSID for the password. So we've actually got 2 separate bugs here. So we don't have 128 bytes now. We've got 2 64-byte injections. And that's actually enough. So here's how we would work. So the first one is writing out the backdoor string, but just writing it to a file, not in just temp A, whatever. And the second injection is catting that file and appending it to the end of the vulnerable time zone script, and then immediately taking a reboot. And my kid pointed out that I had missed the version of Netcat that was compiled with BusyBox, included the NC gaping hole, security hole flag. I'm not kidding, that's actually what it's called. And that was enabled on this particular version of BusyBox for whatever reason. And so here's how you would do it in practice. So the SSID is, again, that echoing the backdoor string to a file. The password is writing that file and concatenating it to the vulnerable script. Remember, of course, we have to encrypt the password before we can use it. And then we combine it all into a single string. And we can see the length for SSID is 60, the password is 59, so we're lower than 64, so it's all good. And then we generate a QR code with that string. And I did ask the staff to see if there were any security cameras in here, and I don't think there are. So that's the QR code that you get at the end of it. And if you take your camera and you point it at that, sure enough, you get a reverse shell, which is awesome. And so, thanks. So you can see the very last line in the extra highlighted red is the backdoor that's been added as a result of the QR code. The rest of it was from the FTP access. And yeah, that's dropped me into, that gives me a reverse shell on port 1234. And it doesn't have to be that IP. Obviously, you choose your own IP. So that's really cool. And so I've decided to take the features that were on the packaging of the camera and redefine. So the smart link actually means a persistent, because it's always there. Every time this camera reboots, you'll get a reverse shell. You get a reverse shell inside the victim's network because, again, it rebooted before it overwrote any config. So it pairs back up with the victim's Wi-Fi. And obviously, once you get the reverse shell, it's pretty straightforward to dump the config file that contains their Wi-Fi network and the password. And you also can upload binaries to allow you to proxy within their network and pivot internally. You also get remote viewing and control, so you can dump the camera's frame buffer and you can look around. Two-way audio control. Yep, I've played Never Gonna Give You Up on the camera. That's just cool. And again, you're root, so you can do anything you want on this device. So, yeah. And you can do all of that in a single QR code. And so I am kind of, I'm not sure of the legalities, but it would be cool if you could get a T-shirt like that and just take long leisurely strolls around the neighborhood just to see what happened. If you're thinking some random dude walking around with a QR code on their t-shirts, that's a little sus. It may interest you to know that that is actually a valid machine-readable QR code. And you can scan it with you can put your camera at it, it's completely safe, trust me. That's the end, thank you.
So thank you so much, John, for that, and appreciate the honesty in the middle there too around, it's easy in a slide deck to just go, hey, I started here and look, shells kind of thing. The bit in the middle around pausing for a bit and actually reflecting and talking, again, presentations look amazing, retrospect's great, but the honesty and the effort in there. We're not going to do Q&A on stage today just because we're streaming and we're going to keep things going, but I imagine you're hanging around for the day, John.
Yeah, I'll be around.
So he doesn't have a QR code shirt on yet, but fine, John, if you've got questions, I'm sure we'll be happy to answer them. Please give John another round of applause.
Thank you. Thank you very much. Thank you too.